In the past, scientists believed that electricity and magnetism were two completely different topics. Electricity was studied using things like glass rods, silk batteries, electric sparks, and lightning. Magnetism, on the other hand, focused on magnets, compass needles, and iron filings. No one thought these two subjects were connected. They were taught separately and explained using different ideas. At that time, electricity was about electric charges and currents, while magnetism was about magnets attracting or repelling objects. This belief continued for many years until an important discovery changed the way scientists understood nature. In the year 1820, a Danish scientist named Hans Christian Ørsted made a surprising discovery. He noticed that when electric current flowed through a wire placed near a compass, the compass needle moved. This showed that electricity can affect a magnet. Later scientists like Ampere and Faraday studied this effect in more detail. They explained that moving electric charges create magnetic fields. They also showed that when magnets move near a wire, they can produce electricity. This proved that electricity and magnetism are not separate, but are closely connected to each other. As Ørsted's findings spread, curiosity ignited among students and scientists alike. Lectures brimmed with excitement as the relationship between electricity and magnetism began to unfold, inspiring future generations. In laboratories across Europe, bold experiments were conducted, revealing the power of electromagnetism. Fascinated minds explored the synergy of moving magnets and electric currents, pushing scientific boundaries. This newfound knowledge set the stage for innovations that would reshape technology and understanding of the natural world. The complete connection between electricity and magnetism was explained by scientists James Clerk Maxwell from Scotland and Hendrik Lorentz from the Netherlands. They developed a theory that showed electricity and magnetism are two sides of the same force. This combined field is called electromagnetism. Today, many natural events around us are explained using electromagnetism. Forces like friction, chemical bonding between atoms, and even processes inside living cells are based on electromagnetic interactions. Because of this, electromagnetic force is considered one of the fundamental forces of nature, meaning it plays a basic role in how the universe works. Maxwell explained electromagnetism using 4 important equations. These equations are as important for electromagnetism as Newton's laws are for motion and gravity. Maxwell also made a revolutionary claim that light itself is an electromagnetic wave. He showed that the speed of light can be calculated using only electric and magnetic measurements. This connected the study of light, called optics, directly with electricity and magnetism. Because of this discovery, scientists realized that light, electricity, and magnetism are deeply related and follow the same physical laws. As the realization spread through the scientific community, new experiments were conducted to explore the connections between these fundamental forces. Researchers began to visualize how electric currents could generate magnetic fields, and vice versa, leading to groundbreaking technologies. The implications of Maxwell's work began to unfold, impacting various fields, from telecommunications to medical imaging, highlighting the profound unity of natural laws. Modern technology is built on the science of electricity and magnetism. Electric power generation, mobile phones, radio, television, and almost all electronic devices depend on electromagnetic principles. When electric charges move, they produce both electric and magnetic forces. However, if we observe these charges from a frame where they are not moving, only electric forces appear. Just like gravity, electric force can act over long distances. In fact, electric force is much stronger than gravitational force. Even though gravity controls large objects like planets, electromagnetic force controls atoms, molecules, and everyday matter.